So okay class, for this week's lesson, we have the shear and moment in beams. First, we're going to define what is a beam. When we say beam, it refers to a slender bar that carries transverse loading. That is, the applied forces are perpendicular to the bar. There are two types of beam. We have the statically determinate beams and the statically indeterminate beams. So class, this was discussed in your statics last time, right? So when we say statically determinate beams, uh, these are those beams in which the reaction of the support may be determined by the use of the equation of static equilibrium. So example of which are these figures: the simply supported beam, the cantilever beam, and the overhanging beam. These are examples of statically determinate. Pag sinabi kasi natin statically determinate, yung makukuha nating equations sa isang figure is the same as the unknown reaction. So if we're going to check, if we do summation moment here, masosolve na natin si R2. Then we do summation forces vertical, makukuha natin both yung reactions nila. The second one is the statically indeterminate beams. So when we say statically indeterminate beams, it is if the number of reaction exerted upon a beam exceeds the number of equations in static equilibrium. So the beam is said to be statically indeterminate. So in order for us to solve the reactions of the beam, the static equation must be supplemented by equations based upon the elastic deformations of the beam. So example of these beams, we have the prop cantilever beam, the fixed or restrained beam, and the continuous beam. So if we do summation forces at this point, we will have an equation having the R1 and M2, hindi na lang iisa. Okay? And if we do summation forces vertical, we will have two unknowns as well. We have the R1 and R2. So that is said to be statically indeterminate beams. For this lesson, we will just focus on the statically determinate beams. There are different types of loads as well. We have the first one, concentrated load. So when we say concentrated load, it acts at a point in a beam. So example is this one. So it acts at a point. Naka-concentrate yung load at a certain point. That is a concentrated load. The next one, we have the distributed load. So when we say distributed loads, it acts over a length of a beam. So distributed are measured by their intensity. So there are two types of distributed load as well. We have the uniform load and uniformly varying load. So when we say uniform load, it has a constant intensity per unit distance. So example of the example figure is this one. Yan. So from A to B, pare-pareho yung load na na-apply sa kanila. So that is a uniform load. The next one is the uniformly varying load. So when we say uniformly varying load, it has an intensity that varies linearly from point 1 to point 2. Ang figure niyan is ito class, okay? So from A to B, nagva-vary siya, but it is in linearly from point A to point B. And the last one class, we have the applied couple. So it is illustrated like this. It is acting like this, couple siya class. So it can be here, can be anywhere in the beam. Okay? Okay, next we have the shear moment equation and shear moment diagram. Class, for this part, we are actually using sign conventions for us to determine the equations and the shear moment diagram. So these are the sign conventions. For the external load, external forces, external loads or the external forces that are directed downward or towards the beam is positive. Yung mga palabas naman, yan ang negative. Tapos yung sa moment naman, this one is external load, is still external load, okay? The moment, kapag positive direction siya or the clockwise direction, that is positive. Kapag counterclockwise, that is negative. For shear forces, the forces that tends to rotate the beam element clockwise. So if you're going to take a look at this, ang rotation nitong dalawa, kasi V, pareho silang V, tas pareho yung intensity niyan, di ba? So if we're going to check this one, the rotation is clockwise. So that is positive. Dito naman sa kabila, counterclockwise, kaya siya negative. And for bending moments that tend to bend a beam element concave upward, the beam smiles. Ito yon. Kapag if we're going to apply the moment like this and it smiles, nag-smile siya, that is positive. Kapag malungkot naman siya, that is negative. Next is the procedure for determining the shear and bending moment diagram. So first, we're going to compute the support reactions from the FBD of the entire beam, and then divide the beam into segments so that the load within each segment is continuous. Thus, the endpoints of the segment are discontinuous of loading, including concentrated loads and coupled loads. After we do that, we then perform the following steps for each segment of the beam. First, we're going to introduce an imaginary cutting plane within the segment located at a distance x from the left of the beam that cuts the beam into two parts. Then after that, we draw an FBD or the free body diagram for the part of the beam lying either to the left or to the right of the cutting plane, whichever is more convenient. Then at the cut section, show the shear, class this one is shear and moment acting in their positive direction. And then after that, we determine the expressions for shear and moment from the equilibrium equations obtainable from the FBD. These expressions, which are usually functions of x, are the shear force and bending moment equations for the segment. Then lastly, we're going to plot the expressions for a shear and moment for the segment. It is visually desirable to draw the shear diagram below the FBD of the entire beam, and then draw the moment diagram below the shear diagram. So that is class the procedure for determining the shear and bending moment diagrams. We're going to discuss further in the examples given. Okay, thank you.